This time on Battle Factory, this lifesaver rolls into the danger zone to neutralize a bomb. A transport vehicle that's battle-ready anywhere, even underwater. And if you have to bail out at 30,000 feet, this Life Raft could mean you'll live to tell the tale. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of aluminum is welded and wired, it will become a robotic arm that can punch through walls, look for suspicious objects, and carry deadly explosives safely beyond the blast zone. Employed by military and police security forces, the robot can go where people shouldn't, to seek out and extract explosive devices for safe detonation. In the chaos of 2013's Boston Marathon bombings, robots played a critical role in preventing further casualties and in the apprehension of the bombers. The robot, named the WM Knight, is made up of the arm, the hazard probe, and the chassis. The chassis is the guts of the robot and what gets it from A to B. It's made from sheets of lightweight aluminum, and each part is cut using a water jet. Water and sand combine under very high pressure to make a precision blade that slices through the metal like butter. Then, the sheet is bent under 88 tons of pressure to form the chassis frame. Once formed and machined, the chassis is sent to a paint booth. The aluminum walls and the air gun are wired with opposite electric charges, which attract, so the thick coat of powdered paint magnetically sticks to the surface. This powder coating is tougher and more durable than a standard paint job. Next, the wheelbases are installed. Then, the gear-driven chain pulleys. Two motors, controlled independently, drive one track forward and the other one backwards to maneuver the robot around corners. The first ever bomb robot was invented in 1972 after 8 British soldiers were killed by IRA bombs in less than a year. A lawnmower was jerry-rigged with a remote control to make the first primitive bomb robot. It's since evolved into a critical life-saving member of every bomb squad. Today's Knight robot comes a long way from the lawnmower. The tires are mounted and encased in a track that will keep them rolling together. This design allows the robot to travel over rough terrain, including deep snow, and even up and down stairs. The arm is cut from aluminum using the same water jet process as the chassis. Then, it's welded together and painted. The arm of the bomb robot is designed to move like the human arm. Its aluminum shoulder, elbow, and wrist move independently. It's strong enough to lift 113 kilograms, and its unique hand grip is precise enough to pick up a paper cup without crushing it. The secret to the precision is in its gearboxes. Each one is outfitted with a complex gear system, allowing the joints to move in multiple directions. The arm's cables, made of copper wires, are the nerves and tendons that connect it to the operator. The cables are threaded into the arm's aluminum skeleton, and the arm is now operational. Kitted out with lights, camera, and an infrared scope, the arm can extend 3 meters in the air to access hard-to-reach spots. And it can be controlled remotely to keep humans out of jeopardy. In the manhunt following the Boston bombings, when the killer was finally found, it was a robot who pulled back the canvas tarp to find him hiding in the bottom of a boat. The HAZ probe, short for Hazard Probe, enables the robot to break through hard surfaces and uses a camera to see what's beyond them. Under the hood of the HAZ probe is an 18-volt motor that powers the drill. It can be outfitted with any number of drill bits, depending on the material it has to get through. Once the hole's been cut, the drill bit pops off, making way for the camera. It can see beyond a wall or even into a suspect vehicle, giving the robotic arm the upper hand. Before the bomb robot can be put into the field, it runs a complete simulation. A gas tank is used in place of a bomb. For this test, the robot has been fitted with a small ramrod designed to break through glass. The arm reaches through the shattered window and lifts the tank out of the car and carries it off for safe disposal. With so many soldiers losing limbs and lives to IEDs, over 3,500 bomb robots have been deployed to Afghanistan. And to date, over 750 of them have been destroyed. But for every robot lost, human lives were saved. Coming up on Battle Factory. If you're lost at sea, this raft can buy you the time you need until help arrives. And a bulletproof, waterproof carrier that can track any terrain to bring personnel to the front line. It will take days for these rolls of watertight fabric to be cut and sewn and fused together. And 7 seconds to put to work. 7 seconds that may make the difference between survival and never making it out of the water. In October of 2011, a search and rescue team of 3 was parachuted into Arctic waters to rescue men trapped in the ice. When their plane had to return to base on account of weather, the rescue team became the victims. After 5 hours in the icy water, 2 of the 3 men survived by waiting in their personal life rafts. The single-person life raft is designed to be stowed in the cockpit of fighter planes. If the pilot ejects over open water, the life raft goes with him. The single-person life raft can be broken down into 3 parts: the hull, the floor, and the canopy. Sheets of bright orange fabric are rolled out. The color has been chosen so the canopy can easily be seen from the sky. Guided by a computer-generated stencil, the electronic cutting station tracks the program measurements, marks the pattern on the fabric, and cuts it out. At the sewing station, Velcro trim is attached to the edge so it can be closed around the body. Velcro is flexible and can withstand the high-pressure vacuum packing required for the ejection seat. A zipper would get crushed. If you're bailing out of a fighter jet, help may be on the way. But if you go down in icy water, death by hypothermia can occur in a matter of hours. This canopy can make the difference between life and death while waiting for help to arrive. The floor is made up of 2 layers of specialized nylon. The first layer is brushed with glue, and dimple patches are pressed into the pre-marked spots. When the floor is inflated with an onboard tube, the dimple patches create a quilted pattern of air pockets, which insulates the survivor from the chilling water. When the raft is assembled, it has to be watertight and maintain its buoyancy. The superglue that does this is made by mixing neoprene and a chemical activator. The glue is mixed daily, and every batch is tested. The bond has to withstand at least 5 pounds of force. If the glue doesn't make the grade, any rafts made with the batch are rejected. Next, high-resistance nylon cord will be placed into the floor to assist in inflation. The cord provides a pathway for the gaps between the layers of compressed nylon. Another cord connects the sea anchor known as a drogue, which slows and stabilizes the raft in high seas. While the stranded search team waited for help in their protective canopies, their Life Raft's anchor also kept them from drifting off course and being lost at sea. The two layers of floor are attached, leaving a tube exposed that will be used for inflation. A rubber inner tube is inflated and attached to the floor of the canopy. While the top of the raft is orange for visibility, the bottom is black, making the Life Raft less visible to sharks. Next, the rapid inflation system is installed. Each raft is fitted with a carbon dioxide cartridge hooked up to the valve on the side of the hull. It'll be used to inflate the raft once it hits the water. Now, the raft is ready to be tested. When it's folded up tightly, it'll be small enough to be fitted in an ejection seat. And in the event of an emergency bailout, it'll be ready to deploy in 7 seconds flat. The single-person Life Raft is ready for duty. And if you're using it, you're probably having the worst day of your life. But now there's a chance you get to see tomorrow. Coming up on Battle Factory, an armored amphibian that will take the troops to the front and back in one piece. When this steel-plated hull is fitted with controls on the inside and tracks on the outside, it'll become a Viking, an off-road warrior that can get troops in and out of any combat zone, even if it has to go through snow, sand, or water to get there. And it can keep its passengers protected, even under fire. In June 2007, a squadron of Vikings filled with British Marine commandos were returning to base in Helmand Province, Afghanistan, when they suddenly found themselves under heavy fire. They had driven into a massive Taliban ambush. The Marine commander retaliated with onboard machine guns and smoke grenades. He was able to lead his squadron to safety with minimal loss of life. He gives credit for their escape to the speed, firepower, and agility of the Viking. The Viking BVS10 is an armored amphibious troop carrier that breaks down into 4 major parts: the wheels, the treads, the rear cabin, and the front cabin. The Viking's bulletproof skin is made of ballistic steel and ceramic plates. The armor for the doors, the hood, and the roof is cut to size using a high-pressure water jet cutter, a combination of water and sand that knifes through the metal with surgical precision. The Viking's 2 cabins hold a dozen soldiers, 4 right up front and 8 in the rear, which can also double as an ambulance or weapons bay for carrying mortars or tank missiles. When the Taliban opened fire on the Vikings with rocket-propelled grenades and heavy machine guns, the Viking's armored exterior protected the men inside. Once cut and bent into shape, cabin pieces are assembled in preparation for welding. A robotic welder lifts and spins the 5-ton cabin into position. Automated torches fuse the bulletproof walls together at exactly the right temperature. Every weld is programmed for accuracy and speed, and every millimeter counts. If the vehicle isn't welded together exactly right, it won't be able to handle the punishment that the rough terrain delivers, and the seams will crack under pressure. It takes 5 full hours to weld the cabin body. The body is designed with flat surfaces to avoid radar detection. The radar echo bounces off the surface in just one direction, which makes the vehicle appear smaller than it actually is. Once the front and rear cabins are complete, they're sent to be painted with an anti-reflective and infrared dampening paint. Once the hull has been painted, it's kitted out with electronics, air conditioning, and navigation systems. The 285 horsepower diesel engine is powerful enough to drive the 1.5 tons of steel at speeds up to 65 kilometers per hour. In the ambush in Afghanistan, the Vikings were outnumbered and outgunned, but they were able to outrun the Taliban and keep them at bay, returning 50,000 rounds of fire from their front-mounted heavy machine guns. And hiding behind a smokescreen of white phosphorus grenades, the Vikings tore over the tough terrain at high speed. The hydraulically controlled articulating joint gives the Viking its ability to move both horizontally and vertically, and handle anything the road can throw at it without breaking up. The girder and wheel system is designed to distribute the Viking's weight evenly, so it can glide over snow or swampy terrain where other tanks would sink. The girders that are the foundation of the wheel system are ground and then robo-welded to exact specs. The hard rubber suspension is what enables the tank to take a pounding. First, a rubber bearing is fit into the suspension. Then, 6 small road wheels are attached to their axles and installed on both sides of the girder. With the Taliban on their tails, the Vikings raced through rocky riverbeds and sharp hills without stalling or getting trapped in the mud. But when the deadly chase finally took them to the edge of the Helmand River, the Vikings had only 2 options: face the fire or swim. Coming up on Battle Factory, the Viking has to resort to its secret weapon. When a squadron of Viking armed troop carriers were ambushed by the Taliban, they found themselves trapped on the shore of the Helmand River. With the enemy on one side and water on the other, the Viking turned to its secret weapon, its ability to swim. It plunged into the deep water. The Viking's unique design allows this 1.5-ton vehicle to glide through the water instead of sinking like a stone. By applying rubber sealant to all the doors, windows, and openings, the watertight vehicle floats due to displacement. Its rubber tracks spin under the water dog paddle style to propel the vehicle forward. The Vikings managed to cross the river and transport the men to safety. Despite being outnumbered 3-1, its armored shell and go-anywhere track system got the troops home with minimal casualties. If you ask the Marines on the ground, they'll tell you without hesitation, if not for the Viking, nobody would have made it home alive. The final step is to attach the rubber tread. The hard-molded rubber is tough enough to keep on moving, even if the Viking rolls over an anti-personnel landmine. To install the track, the Viking is lifted off the floor. Then the tread is rolled over to the vehicle. A tread wheel is attached, and the rubber track is stretched tight over the road wheels. Now, the vehicle is complete and ready for testing. First, the water test. The Viking runs the test course like a true amphibian, plunging into 3 meters of water and gliding along at full operational capacity. This test ensures that the cabin is leak-proof and that the Viking can maneuver underwater. Next is the terrain test, ripping through the deep mud and scaling up a 31-degree grade without slipping. True to its name, the Viking is built for battle on land and in the water. No matter what and no matter where the mission, the Viking can get you there and back in one piece. This time on Battle Factory, a helmet that's easy to wear and tough enough to take a bullet. A pocket-sized icon that's been lighting up the fight since World War II. A mobile filling station that fuels the front lines. And a simulated explosive that trains the mind for war. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these delicate snowflake shapes are pressed together, they'll form a piece of headgear that's comfortable enough to wear to war and tough enough to take a bullet. On October 3rd, 1993, a squad of U.S. Special Forces rappelled out of two Black Hawk helicopters onto the streets of Mogadishu, Somalia, in an attempt to seize two enemy lieutenants. The operation went south when the Somalis shot down the choppers and stranded the forces in an overnight standoff that inspired the movie Black Hawk Down. The Special Forces ops were willing to risk injury or worse rather than wear the uncomfortable Army-issue helmets that blocked their vision and messed with the communication system. So instead, they wore hockey helmets to the firefight. U.S. casualties were high. A plan was put into effect to design a helmet that soldiers could wear that would protect them in situations like the Mogadishu standoff. By the time troops shipped out to Iraq, the Special Ops helmet had been transformed into a ballistic helmet with mobility, visibility, and comfort. The Special Operations Delta helmet breaks down into two parts: the attachments and the body. The helmet is made from a synthetic plastic material called Aramid. Sheets of the material are rolled out onto a cutting table and stacked on top of one another. It's the layering that makes the helmet anti-ballistic or bulletproof. Fibers are so tightly woven that the projectile gets caught in the web and expends a lot of energy trying to push through. More layers means more protection. Patterns are laid over the Aramid sheets and cut with a bandsaw. The operator wears a chainmail glove to make sure he only slices through the material. The Aramid is cut and piled into snowflake-shaped stacks. The stacks are rolled over to the press. Individual sheets are laid onto a mold in an overlapping pattern. Steamed heat and 150 tons of pressure fuse the layers together to form the helmet shell. Paint won't stick to Aramid, so once the shell is complete, an additional paintable layer is pressed on to form the outer surface. The helmet is hand-trimmed to remove the excess material. Holes are drilled for chin straps and rails for mounting optical gear. Up until the mid-90s, helmets hadn't evolved that far from the steel doughboy helmets of World War I. In Mogadishu, Special Forces were more likely to wear cloth caps than to be weighed down with a helmet that offered little in the way of real ballistic protection. When they did wear helmets, they were likely to be $40 adjustable hockey helmets to protect them from banging their heads, not stopping a bullet. So a helmet had to be developed that offered the same comfort as a hockey helmet, with the ballistic protection and utility of combat gear. One helmet from each batch is tested by simulating a worst-case scenario: a bullet to the head. A helmet is positioned 5 meters from an automated 9mm rifle. The rifle is loaded and fired. A bullet travels at almost 440 meters a second, directly into the helmet. And while it does damage to the outer shell, it doesn't pierce it, which means in combat, it just saved a soldier's life. Once the batch has passed the ballistics test, the helmets are trimmed and a rubber edging is applied. Now the helmets are ready for painting. Once the paint is dry, the helmet gets a camouflage coating using a process called hydrographics. The 5-color print comes on a film, which is cut to size and placed on the water surface. A chemical spray both dissolves the film and activates a bonding agent. The helmet is dipped into the vat through the print, which floats on the surface like an oil slick. The pattern sticks to the helmet, then a top coat seals in the design. The inside of the helmet is fitted with an adjustable harness, neck pad, and shock absorber inserts. The outside of the helmet is kitted with rails to mount tactical equipment like lights, gas mask, communication equipment, and night vision. All the comforts of a $40 hockey helmet with the necessities of modern warfare. So wearing it shouldn't be an option. It's just using your head. Coming up on Battle Factory, it didn't just light fuses and heat rations. This wartime legend even stopped a bullet. And these portable containers carry enough fuel to power an army. These ribbons of solid brass will get pressed into service as an icon that's known by its look, its sound, and its name, the Zippo. When the U.S. entered World War II, Zippo started building their lighters exclusively for the U.S. military. On the front line and in the foxholes, GIs found comfort in a battlefield smoke. From World War II through Vietnam, Zippos have played their part in the war effort to light fuses, hammer nails, and heat rations in a helmet. There's even a story that a Zippo, sitting in a shirt pocket, saved a GI's life by stopping a Viet Cong bullet. The Zippo lighter breaks down into the insert, which houses the fuel tank, and the outer case. To make the outer case, 1-ton coils of pure brass are spooled out to a stamping machine, where 60 tons of pressure produce the lighter bottom. Then, a hinge and the two halves of the outer case are slid into welding braces on a moving table. Next, an electrode welds the hinges to the case. The flip-top case is what gives the Zippo its distinctive sound. The cases are loaded onto hanger frames and primed for their chrome plate finish. First with a nickel bath, and then with a cleaning solution. Zippo has a long tradition of specialty engraving, which makes the lighter highly collectible. But some of the most sought-after Zippos are those personalized by the servicemen themselves. Called trench art, soldiers would engrave their names and messages on their Zippos. For many, their inscriptions became their epitaphs. The insert is made from stainless steel and shaped in a die-cast machine. The inserts are transferred onto a conveyor belt. The flints, or spark wheels, are loaded into an assembly jig, followed by the cams, which will eventually act as a catch for the lighter lid. The cam is what keeps the Zippo lid shut. A wick is inserted and cut. Then, all the remaining elements of the insert are added. Finally, a flint screw is driven home to hold everything in place. The completed insert is press-fit into the outer case. The Zippo gets a once-over, a final buff, and it's good to go. For over 80 years, as a veteran of countless military theaters, over 500 million Zippos have been produced and have lit up the lives of 3 generations of service men and women. Coming up on Battle Factory. No matter where the fight takes you, these fuel containers can keep your motor running, and a simulated battleground prepares the soldier for the real thing. When it's cut and welded, this military-grade material will make one tough plastic bag. And it better be. It's going to carry 125,000 liters of diesel and jet fuel, enough to service tanks, jeeps, and planes, wherever the front line is drawn. In war, fuel becomes a target. How that fuel gets to the front line can make the difference between winning a battle and losing lives. In World War II, fuel was transported and stored in heavy metal barrels. When the barrels came under fire, they either exploded or all the fuel was lost. Now, there's a portable filling station that can gas up a tank in minutes and take a bullet without exploding. The mobile filling station breaks down into 2 parts: the fuel container and the pump. The military-strength pump will be housed in an aluminum cage to keep the machinery stable and protected. Once the cage is assembled, the pipes and hoses are fitted, the meter is attached, and the pump's engine is mounted into the frame. These military-strength pumps can fill a tank at up to an incredible 950 liters per minute. If this pump were used on an average car, it would likely take only 7 seconds to fill the tank. In the combat zone, fueling a tank has to happen fast, or they're sitting ducks. The fuel tank is not a conventional one, but a large foldable and reusable container. The bag is made from a top-secret formula of polyurethane and nylon. Each one is designed specifically for the type of fuel it's carrying and for where it will be deployed. And the shape is also not an accident. When a bomb goes off, it's the shock wave that can take out a vertical structure like a barrel instantly. But with these low-profile containers, the shock waves run into little resistance, so they roll right off the top of the container. In World War II, gasoline was stored in heavy metal barrels and pumped from large metal tanks. If the tank was pierced by a bullet, it had to be drained completely before it could be repaired with a welding torch. When these fuel containers come under fire, the hole can be plugged in seconds with a temporary screw plug, then permanently repaired with glue. To construct the fuel container, the sheets are joined together using radio frequency welding. Working like a microwave, it liquefies the top urethane coating from the inside out. The result is there's no longer a seam left. The pieces are bonded together at the molecular level. These seams will last for 10 years. There are 2 holes in the fuel container called flanges. One on top is used to pump fuel into the container, the other to pump it out. And the seal around those holes is critical. To make sure the fuel container is field-ready, every seam, seal, and flange is tested. The bladder is overinflated with air, and a soapy liquid called leak tech is brushed on. If there's a leak, a bubble will form. An air leak here means a fuel leak in the combat zone. Thousands of dollars of fuel could be lost and put lives at risk. It passes the test and is ready for action. The container is then folded, loaded up, and prepped for travel. 6 of these mobile fueling stations can fit in an average shipping container. This is the equivalent of 8,700 metal barrels. In fact, Europe is still cleaning up the mess from World War II. Barrels are still being found today. Once it arrives on site, the folded container expands to 10.5 by 10.5 meters with a capacity of 125,000 liters of military-grade fuel. Each one holds enough diesel to gas up 107 Leopard 2 battle tanks. That's the equivalent of over 2,000 cars. Whatever the mission, these containers will fuel the fight. Coming up on Battle Factory, these special effect explosives mean gaining battlefield experience without losing your life. This aluminum bar is about to be transformed into a revolutionary training tool that could make the difference between life and death. Landmines and IEDs, or improvised explosive devices, are as lethal as they are terrifying. They've killed more than 3,000 troops and wounded 3,000 more since coalition forces landed in Iraq and Afghanistan in 2003. IEDs and landmines are often buried and triggered with a cell phone or remote control. Tough to spot and deadly. One wrong step could be your last. These surprise attacks cause panic and confusion. The first instinct is to freeze. But when you freeze, you become a target and a liability to your squad. In the past, it's been impossible to mentally prepare for these deadly threats without putting the soldier's life in danger. Now, a military simulation special effects company has created the ultimate training tool. When detonated, they unleash a sensory assault without causing injury. A soldier learns to handle the sounds and smoke of an IED blast while keeping his cool and carrying on with his mission. Explosion effects simulators break down into 3 parts: CO2 cartridges, the remote control, and the canisters that generate noise and smoke. Using precision craft and aluminum parts, assembly can begin. The first step is the burst disc, which seals the canister. This will house the special effects powder. It's locked into place with a robotic press. The components are pressure fit to complete the canister, and now work can begin on the remote detonation system. To replicate battlefield conditions, the explosion effect simulators have to be triggered from a distance. All the component parts of the remote detonator are soldered, tested, and fitted into a durable housing that can be stowed out of sight or buried underground. The detonator sends low-frequency pulses to the canister. It can receive a radio signal from up to almost a kilometer away, as long as there is a clear line of sight. The U.S. military has mocked up a number of Afghan villages to simulate the sights, sounds, and even the smells of a combat zone. Marines are subjected to immersive training scenarios, bombarded with the extreme mental and physical stresses of insurgent IEDs and street-level firefights. These high-stress simulations train the soldier to adjust fast and perform better in real-world situations. The trainer prepares for the field test by arming the explosive effect simulator. Each cylinder is filled with FX powder that will discharge a blast of smoke and a pressure cap that will produce an ear-splitting boom. CO2 cartridges are locked and loaded into the back of the canisters. On the training field, the explosion effect simulator is tethered to the receiver and hidden from sight. Anticipation and heightened response time can be the best weapons against an enemy when the rules of engagement don't apply. Learning to stay cool and maintain focus in this simulated attack psychologically prepares the soldier for the real thing. It could mean saving his own life or that of a buddy when he's in the chaos of battle. This time on Battle Factory, a combat suit for hiding in plain sight. A troop carrier with teeth that'll bite into any terrain. A pump truck that can shoot on the move. And a new take on a classic sidearm. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. To do his job and stay alive, a sniper needs to keep the target in range and stay out of sight. A sniper may position himself as far as 2 kilometers away from his target. And like a chameleon, he needs to blend into his background. And for that, he'll need a ghillie suit. The ghillie suit breaks down into the living layer, the burlap, and the smock. Ghillie suits are the ultimate camouflage, handcrafted by the sniper himself during training. It starts as a smock made from fine netting. The entire uniform is sprayed with an anti-reflective compound that reduces infrared signature to make it less detectable by night vision and thermal imaging scopes. The shoulders, arms, and chest area are softened so it looks less like a human form. The way to achieve this is with thousands of strands of material looped into the uniform's smock. Unraveled burlap looks natural and works best. The burlap is pulled apart by hand until there's enough thread to cover the suit. To match the foliage, some of the burlap is dyed. The multicolored strands are threaded into the netting to create uneven patterns. The burlap threads are tied to the mesh, covering the back, shoulders, arms, and chest. The softened silhouette will disappear into the background. Every sniper is an elite soldier, a sharpshooter in top physical and mental condition. During training, snipers spend over 100 hours of their own time hand-making their ghillie suit. It's part of the rite of passage. The same mesh burlap combination that covers the uniform is turned into a head-covering veil that hides the sniper's face and obscures the firearm. Ghillie, which means green man in Gaelic, was first invented by Scottish shepherds, hired by the landowners to protect their flocks from poachers. The Lovett Scouts, a Scottish Highland regiment formed by the British during the Boer War, were the first soldiers to use ghillie suits. And in 1916, became the British Army's first sniper unit. Once complete, the ghillie suit is distressed by dragging it through the dirt. Finally, the suit is sprayed with a fire retardant to make sure sparks from the rifle don't ignite the flammable burlap fibers. In the field, the sniper collects local vegetation, fastening bits of twigs, leaves, and grass to form a suit that's a perfect match for the surroundings. In every sniper force in the world, ghillie suits are as much a part of the sharpshooter's kit as his rifle. Coming up on Battle Factory, a tough transport vehicle with a customized weapon system, and a fire truck for when the blaze goes beyond the city limits. When these ballistic steel plates are cut and shaped and welded together, they'll make the body of an armored personnel carrier that's built to be fast and flexible. The CV-90 is the next best thing to a battle tank, but faster and more maneuverable. It can be fitted with or without a turret, with weapon options that include machine guns, cannons, and grenade launchers. The CV-90 is the Swiss Army knife of heavy artillery. It can be customized to suit the mission. In 2007, in Afghanistan, the CV-90 first saw action during Operation Harakati Yolo, a ground offensive to oust Taliban militants from northern Afghanistan. The CV-90, carrying a Norwegian battalion, took heavy insurgent fire. In a high-speed chase over hostile terrain, it outran the enemy, then returned fire with machine guns and cannon rounds, until the CV-90s were able to beat back the Taliban and get the troops safely home. The CV-90 Armadillo breaks down into the turret and the tank body. The CV-90's armor plating starts out as laser-cut sheets of bulletproof metal. The automated beam also carves out holes for sights, cables, and weapon stations. Then, the precision-cut sheets are bent into shape under 1,800 tons of pressure. And now, all the pieces have to be assembled. The first step is to temporarily weld the pieces together. The body is hoisted onto a robotic welder that automatically performs thousands of accurate welds. The same job would take a team of human welders weeks to accomplish. But after a full day on the automated welder, this job is complete. Flaws in the welds aren't usually visible to the naked eye. The only way to find them is with an X-ray machine. There are critical spots on the CV-90 that will take the brunt of the weight when it's deployed. When the 35,000 kilo CV-90 hits a bump in the road at 70 clicks an hour, even a hairline fracture could put the whole frame out of whack. At the measuring station, techs use lasers and handheld probes to make sure that every surface and angle is accurate. The probe can tell if it's off by more than 0.05 of a millimeter, and if it doesn't line up with the other components of the vehicle, it won't be able to accommodate the modular weapon system. This particular CV-90 will be armed with a dual grenade launcher. Construction begins with the turret mounts. The turret is cut, bent, and welded using the same construction techniques that built the CV-90 body. This same turret can be customized with multiple weapon configurations, from as small as a .50 caliber machine gun, all the way up to a full-sized battle tank cannon. Wiring and cables will connect the turret to computer controls. If everything functions perfectly, the turret will be secured to the CV-90 body. Before the CV-90 sees active duty, it has to pass the test track. Running at 60 kilometers per hour, speed bumps are designed to rattle the frame, and then it's sent into the field to push the vehicle to its limits. This one tackles the terrain without breaking a sweat. The CV90's options may change with the mission, but the objective is always the same: make it back alive. Coming up on Battle Factory, the fire truck you need when you have to take your water with you, and a 45 semi-automatic that's a century in the making. When this aluminum tank is finished, it'll hold 3,700 liters. That's enough water for a small swimming pool, or to put out a good-sized blaze. And it'll be sitting on the back of a mobile fire truck. Because when you can't connect to a hydrant or pumping station, you've got to take your water with you. In times of war, firefighters can't rely on conventional water supplies. During the London Blitz, thousands of camouflage water tanks were hidden throughout the city, and pumps were installed under the bridge to siphon water out of the Thames. In peacetime, the mobile fire truck is often dispatched to handle wildfires. And in war, it's often sent to places with no access to water. The Grizzly Pumper fire rescue truck breaks down into the water tank and the pump house. The pump house is the heart and brains of the fire truck. Gauges and wires are housed in an aluminum cabinet, which sits in the middle of the truck body and controls the pressure of the water jets. The pump house is fitted with pressure gauges and the wiring system that controls the power and temperature of the water jets, so the water doesn't freeze even at 40 below. The pump house cabinet is made up of 77 kilo sheets of marine-grade aluminum, which are fed into a hydraulic guillotine shear with 78 kilopascals of pressure that slice through the 5mm sheets. Then, the aluminum is bent into shape using a press brake. The cabinet is attached, and the pump house is complete. On this fire engine, the pump house is connected to the vehicle's main drivetrain, which powers a pump working at 4,700 liters per minute, or 5 times the pressure of an average garden hose. This pump and roll capability means the truck can spray water on the move. During the Bosnian War, fire trucks equipped with onboard water tanks fought the flames during the siege of Sarajevo. The subframe is made from high-strength aluminum, tough enough to hold the 3,700-liter tank. The subframe is cut and fused using metal inert gas welding. It keeps out impurities and strengthens the bonds. Then, the side cabinets are cut, shaped, and welded. The aluminum surface is buffed with the sander to prime it for painting. The subframe is then added to the side cabinets, forming the enclosure that'll hold the water tank. It's got a 14,000 kilo maximum capacity, so it can easily support the tank, which weighs about 4,000 kilos when full. The fire engine starts its life as a stock cab and chassis. Once the truck bed is ready, the pump house is lowered onto the chassis. Instead of transferring the heavyweight rear cabinet and subframe to the truck bed, it's hoisted over the shop floor so the truck can get underneath it while it's lowered onto the frame. Then, the tank is dropped in. The pump house is connected and wired to the truck's computer. This controls the water flow and makes sure the pressure doesn't get dangerously high. A remote-controlled nozzle is mounted on the front bumper, which can pump out a constant 250 pounds of water pressure per square inch. That's about 500 times what comes out of your kitchen faucet. The seats installed in the truck's cab include built-in oxygen tanks, so when the firefighter mounts up, he can slip right into his air supply. For additional O2, extra tank holders are bolted to the cab exterior. The ladder is slid into a side compartment. Lights are installed. Now, this fire engine is ready to battle any blaze. No matter where the call, the Grizzly Pumper Rescue Fire Engine can bring the fight to the fire. Coming up on Battle Factory, the military's most enduring sidearm aims high. This block of steel will be transformed by innovation and artistry into the ultimate update of an American classic. An iconic sidearm and a formidable weapon. The 1911 semi-automatic handgun was invented over a century ago by second-generation gunsmith John Moses Browning, one of the fathers of modern firearms. The 1911 did tours of duty in both World Wars and Vietnam, and is still prized today by collectors and enthusiasts. The design has changed very little in the last 100 years. The 1911 breaks down into the slide and the frame. The frame of the Cabot 1911 is carved out of a high-purity block of steel with a water jet cutter. Water mixed with sand can slice through the thick steel with ease. What comes out of the water already resembles the 1911 signature profile. Once it's been cut, the body is machined on a CNC, or computer numerical controlled router. Water and lubricant flood the machining compartment to cool the metal and reduce friction, while the body details are tooled and holes are drilled to exacting specs of a 0.025 millimeter tolerance. The pistol body is again submerged in water, this time to conduct electricity. With both the metal and water electrically charged, intricate detailing is done using an EDM, or electric discharging machine. Stainless steel wire is charged with an electric current at 300 volts, then run through the magwell, carving the fine details onto the steel surface by literally burning off metal particles. The 1911 is now ready for engraving. The body is placed in a jig, a device that holds the gun steady for engraving. Using a cutter, the engraver etches out a serial number and the company details so that every 1911 can be traced back to the day it was made. The slide of the gun is cut using the same water jet cutting method as the body. The spring-loaded slide of a handgun is pulled back to cock the hammer, then grabs the cartridge and pushes it into the chamber of the barrel on its way back. After it's cut, the slide is placed on a grinder and shaped to perfection so that it'll marry perfectly with the body. The measurement is so exact, it's the equivalent of splitting hairs 30 times over. Using a surface grinder and drawing on years of muscle memory, the final filing is done by an experienced hand, smoothing out the surface. What makes this gun special is that it's constructed to fit together perfectly without any adjustments or alterations. Called clone technology, the frame and slide are probed inside and out with a coordinate measurement machine to make sure they conform to exacting measurements. The measurement room has to be exactly 20 degrees Celsius. Plus or minus 1 degree can cause the steel to expand or contract. Finally, the gun is treated and assembled. Since its creation in 1911, the semi-automatic pistol has been an icon and the stuff of legend. But the most incredible 1911 story comes from World War II, when Lieutenant Owen J. Baggett's plane was shot out of the sky over India. He bailed out, only to become a floating target. A Japanese Zero fighter plane was headed straight for him, machine guns drawn. At the last moment, Baggett raised his holstered 1911 and fired 4 shots into the cockpit. The Zero went into a nosedive. One man took on the most notorious Japanese fighter in the sky with nothing but his 1911 sidearm, and he won. For over a century and through countless battles, the 1911 has been locked, loaded, and ready for action.